Alright, so now we'll be talking about concepts, descriptions, and all the concepts related to SNOMED. So concepts are stable units of meaning. They represent clinical ideas like myocardial infarction or pneumonia. They have machine-readable IDs, so concept IDs these are known as, and they are integer identifiers and are unique, which ensure stability even if text labels change. For example, this is the ID corresponding to myocardial infarction disorder, and this is the fully specified name because it has the suffix giving the primary hierarchy of this particular disorder, right? Now, concept-oriented model, unlike ICD, which is more classification-oriented, SNOMED CT is concept-based. Every piece of clinical information is modeled as a concept, not just a code. Now, moving on, what are descriptions? So, descriptions are basically human-readable forms linked to concepts. They provide a context to the concepts that have been mentioned, right? Now, every concept has two descriptions. That is, firstly, we have the greater than or equal to two descriptions. That is, there could be three as well. So, firstly, we have the fully specified name, that is the FSN, which is unique and unambiguous, and it includes a hierarchy suffix in parentheses to indicate context. This is the hierarchy suffix disorder, and it is not meant for the end users. Then we have the preferred term or the display term, that is usually in the clinics that you go to. These are the norms. These are the terms that are commonly used. So commonly used clinical label, often FSNs without the suffix, so without this, just the name, right? Now synonyms, alternate terms clinicians might use, labeled as preferred or acceptable per language reference set, right? For example, heart attack, that is myocardial infarction, and in common terms it is known as heart attack. Now, why is it important? Multiple languages, specialties, and regions can use different synonyms, but all map to the same concept ID, which is unique, and it enables semantic interoperability, right? That is, we can exchange information and use that information, and it is better to, for example, if we mention myocardial infarction to someone who does not belong to the medical field, they might not know what is the condition that has happened to the patient. So when we say heart attack, there's a high probability that the person will know definitely that what a heart attack is. So that is why it enables semantic interoperability, right? Now, talking about relationships, so SNOMED is more than a dictionary; it's an ontology. There are two types. First is a super type, that is a relationship. It defines the taxonomy or the hierarchy that we have. So concept ID, if we have this, that is a relationship. Myocardial infarction is a disorder of the heart. So these are is a relationships, which are parent-child relationships. Now, secondly, we have the defining attributes, that is properties that distinguish one concept from another, right? So pneumonia, causative agent is Streptococcus pneumoniae. Finding site is lung structure. So this is the defining attribute, that is the causative agent and the finding site. These distinguish one concept from another. Next, we have fully defined versus primitive concepts. So fully defined is basically defining relationships that are sufficient to uniquely place the concept. And for example, type 2 diabetes mellitus attributes disorder of glucose metabolism, not insulin dependent. Now, primitive is basically incomplete definition. It cannot be distinguished solely by attributes. For example, pneumonia without specifying the causative agent or the finding site, right, as we did here. And implication is that the large parts of SNOMED remain primitive, which is why reasoning plus post-coordination are essential. Now we have the expression. SNOMED allows two ways to capture clinical ideas. First is the pre-coordinated one, that is the single concept ID represents a whole idea. This is the single concept ID, pneumonia caused by Streptococcus pneumoniae. Second one is the post-coordinated concept ID, that is using multiple concept IDs, composition of multiple concepts using attributes. So concept ID, concept name, attribute ID, value, concept ID, then attribute ID2, value, concept ID2. So this is how we show it. For example, this is the concept ID, then the concept name is pneumonia disorder. This is the attribute ID, causative agent is this Streptococcus pneumoniae. Then the finding site, lower lobe of right lung. So captures long tail clinical detail without exploding pre-coordinated code lists. Next up, we will talk about going over to the part where we are discussing the concepts. So I think we have already covered concept, which is the atomic unit of meaning in SNOMED CT. It's an abstract language independent representation of a clinical idea. Myocardial infarction. Concepts are stable and intended to represent the clinical meaning, not a particular text label. Right. Then we have SNOMED CT identifier. Each concept is assigned a unique numeric identifier, an integer. These IDs are what systems exchange and persist to guarantee a stable machine-readable reference. IDs do not carry meaning themselves. The meaning comes from the concept's relationships and descriptions. Description is textual human-readable terms attached to concepts. Each description is a separate SNOMED component with its own ID and attributes, language, case significance, acceptability. And descriptions are not the canonical meaning. They label the meaning. Multiple descriptions can map to the same concept. Then we have relationship, which is a directed edge that links one concept to another or to a concrete value. Two primary kinds we have is a supertype, that is establishing taxonomy or the subclassing. An attribute has a role, defines meaning. For example, finding site is lung structure, causative agent is Streptococcus pneumoniae. So the attribute that is has a role, right? Then we have relation types themselves representing themselves as concepts. Then ontology, SNOMED CT is ontology, a formal model of domain concepts plus the relationships, axioms that let the machines infer, classify, and check consistency. And we talked about descriptions, that is fully specified name. So let us go through this again. Uh, Fully specified name is a single, unique, unambiguous name for a concept per language or language reference set. Includes a suffix in parentheses to indicate the primary hierarchy. For example, myocardial infarction disorder in parentheses in the suffix. Purpose is that it allows us to have an unambiguous identifier for human readers and for auditing, not intended for everyday clinical display. Rule is one FSN per language or locale per concept. Preferred item, then we have preferred term or display term, that is the user facing label that clinicians see. Often it's the FSN without the suffix or a regional variant, for example myocardial infarction without the suffix. Now the preferred term is chosen per language reference set, that is language reference set, ref set, and marked as preferred. Then we have synonyms, any additional alternate labels for the same concept. For example, the common synonym that we use is heart attack, and it is very well known. This is not very commonly known unless you either belong to the medical field or you have some family members, or you've already experienced it in your close circles. You won't know this term, right? Myocardial infarction. So the most common term used as a synonym is heart attack. Then we have acceptability flags. Synonyms are marked preferred or acceptable per language ref set. Only one concept description pair is preferred per local. Now description metadata. We have the description ID, that is the unique ID for description component. Then we have the term text, that is the string. Then type field, type ID, which is basically the FSN versus synonym versus text definition type. Language ref set, membership acceptability. Determines which description is preferred in which language or country. Then we have the case significance, whether the case matters, that is uppercase or the lowercase, right? This or this. Active flag and effective time module ID for versioning, right? Practical tips to use is always store a concept ID in the database. Store display string only for UI convenience. Do not use free text as the canonical key. Use language ref sets to deliver correct display text by locale. Then we have relationships, taxonomy, and attribute relationships. So firstly, we have the is a supertype relationship, a hierarchical relation that says A is a B, that is A is a subtype, child of B, right? A is a form of B, right? Or a child of B. Myocardial infarction is a ischemic heart disease. Properties: each concept except the root has at least one is a link, right? And chains of is a create the taxonomy, that is a directed graph. Now, inquiries and serious rules. A rule on infectious disease applies to any concept having is a infectious disease. Then we have the attribute type, that is the concept, the attribute type, and the value concept. That is, if, for example, pneumonia, causative agent, streptococcus pneumoniae. Attributes are typed. So, like causative agent, finding site are themselves concepts, that is, relationship types that are modeled as concepts. Now, multiplicity, each concept may have 0 to n attribute relationships. Some attributes may be required to fully define concepts, others are optional refinements. And we have role groups and attribute groups. So SNOMED supports the grouping of attributes that logically belong together. For example, a fracture with associated fracture site and laterality grouped. These are often modeled as role groups, sometimes called attribute groups. So the classifier knows which attributes apply together. And then we have the concrete attributes. Some attributes accept concrete values, numbers or strings. Others accept concept values. Now, finally, we will be talking about fully defined versus primitive concepts. So fully defined concept is whose defining relationships are sufficient to distinguish it from its siblings or supertypes, as the attribute set gives both necessary and sufficient conditions. As a consequence, a reasoner can reliably place all equivalent concepts, expressions under the same node and determine the logical equivalence. Then we have the primitive concept, that is a concept that is not fully defined. It lacks a set of relationships that uniquely distinguish it. For example, plain pneumonia without specifying causative agent or site remains primitive. Reality is that large portions of SNOMED remain primitive. Clinical content often uses post-coordination to add the necessary details, right? And this is the difference between pre-coordinated and post-coordinated expressions. So a pre-coordinated expression is a single pre-built concept identifier capturing the full clinical data idea. And for example, a pre-existing SNOMED concept for left lower lobe pneumonia due to streptococcus pneumoniae, if such concepts exist. And it is easy to store and query, widely used when the concept already exists. Cons is that it is not scalable for every possible combination. While post-coordinated expression is a composition of multiple concept IDs, and we build meaning by combining concepts with attributes. So this is the common syntax used: concept ID, concept name, attribute ID, value concept ID, attribute 2, value 2. So pneumonia, causative agent, streptococcus pneumoniae, finding site, right, lower lobe, right. And attribute groups, role groups, and nested grouping may be required to indicate which attributes apply together. And post-coordination rules, many implementers restrict which attributes can be combined for a given concept. Unconstrained free post-coordination can create ambiguous or logically invalid expressions. Now, complexity, attributes can be filled by either concepts or concrete values. You can nest expressions. For example, value of attribute itself is a composed expression. And that's all.